Hi again. So in this video, we will talk about event relationships. Let's start with the mutually exclusive events. So we can say that A and B are mutually exclusive only if their intersection is not, or in another word, they cannot occur at the same time. So if A happens, B will not happen. So how can we write this? So A into B is an empty set or is null. So the probability is null actually. An example, if rolling a dice give our omega, which is from 1 to 6, the two events here are A getting an even number and B getting an odd number. As you can see, we cannot have a number that is even and odd at the same time, so they have nothing in common. So their intersection is an empty set. We can write the cardinal of their union as this. So it is the cardinal of A plus cardinal B. Simply, we didn't add this term of minus card their intersection, because simply this is 0 actually. So we can write the formula directly like this. Now another relationship is complementary events, and the complement of any event, let's say A, contain the all the outcome in our sample space that are not in A, which means A, let's call it A bar, which is the complement of A, or AC, the complement, is omega minus A. So A, if we add the A bar, we get omega. In another word, A union A bar is omega, and the probability of A plus the probability of A bar is 1. 1 because it's cardinal of omega over cardinal of omega, and we get 1. Example of complement event, getting, if A is getting an even number, B is getting an odd number. So this event is the complement of this, and this is the complement of this, because together they form the omega. They have nothing in common, and together they form omega. Now let's back to the mutually exclusive event. Here we have A, which is an even number, 2, 4, 6. Then we have B, which is 3 and 1. What we can see here, what we can observe is that B bar, which is the complement of B, contain anything in A. So if they are mutually exclusive, if B and A are mutually exclusive, we see that it is A plus the remaining, or the omega minus, here it is 5, minus their union. What does this mean? It means when A and B are mutually exclusive, automatically we get A is a subset of B bar. Now let's see in case they are not mutually exclusive. For example, here we have A is the same, so getting an even number, 2, 4, 6, while B is getting 5 and 4. Now in this case we have a common factor, which is here 4, so they have something in common. So if I take B bar, what part of A is contained in B bar? Actually only this part. We cannot take 4 because 4 is not in B bar. 4 is not in B bar. So the part of A contained in B bar is A, but without the intersection of A and B. So now we can write a minus a inter b is a subset of b bar. Now let's see this concept of subset and let's get some properties from it. So what a is a subset of b, or is a strict subset or subset, we write it like this. So if a is subset of b, that means if the event a happens, b must happen. So all the elements in a, we find them in b. An example here, a is 2 and 4, b is 1, 2, 3, 4. So any element in a is contained also in b. So we have to know that if a is a subset of b, then the following is instantly true. The first is a inter b, a here inter this, so the smallest is the result, so it is a. And a union b, if we take a, we add it to the b, the union, you get only b because a is the smallest, so we take the largest. So this is the rule. So if a is a subset of b, if a is a subset of b, the intersection of a and b is the smallest, which is a, and the union of a and b is the largest, which is b here. Now let's back to this relationship. We said when they are mutually exclusive, a is a subset of b bar, which means since a is a subset of b bar, that means that a inter b bar is, we said, the smallest one, which is a. And now here also, since a minus a inter b is a subset of b bar, so that means the a inter b bar, in case they are not mutually exclusive, it is a, but this time we need to remove the intersection a inter b. So a inter b bar is simply a minus a inter b. And now let's see how to deal with this subtraction. So how to subtract an event from another event. So a minus b, we can write it like this, a minus b means that event a occur but event b doesn't occur. So what we want exactly is a part of a that has nothing to do with b. For example, here we have b in the blue circle, 2 and 4. We have a with the green circle, 1 and 2. So here we want a minus b here. So what we want here, actually anything in a, but we need to remove what we have in b. So what do we remove here? For example, here we want anything in a, so it's 1 and 2, but we don't want what we have in b, what we have in b and a at the same time. So we need to remove these two because it is in b. So it is simply a minus a inter b. This is the subtraction in event. So a minus b is a minus the intersection, and we saw here that a inter b bar is a minus a inter b. This one we said only if they are not mutually exclusive, because if they are mutually exclusive, this one is null, so it is just A. Now let's back here. So we have this formula: A inter B bar is A minus the intersection, so this A inter B bar also is simply A minus B, and it is written here in this formula. So A minus B is A inter B bar, and those formula are very important. So in the next video we talk about some other properties. Again, those formula are important, you need to understand them, and also the properties we will talk about the next video are also important, so you need to understand them. We talk about the De Morgan law, we talk about distributive law, and some other properties. Thank you for watching, and see you in the next video.